Okay, Wildcats, today we're going to journal page 51, cube and cube root inverses. Four ways to find the inverse, f inverse of x. 1. Graph, reflect over the y equals x line. 2. Table, switch x and y. 3. Algebraic, switch x and y and resolve for y. 4. Composition of functions. F of g equals fg of x equals x, and when g of f equals g of f of x equals x, when the result of f of g and g of f is x, then f of x and g of x are inverses. And then a special note, when it comes to inverses, domain and range will switch. Okay, if you would update your notes. Okay, now your notes are updated. Let's take a look at the examples. Let's zoom in a little bit. All right. Find and graph the inverse f of x. Okay, the first thing we need to do is graph f of x equals x cubed plus 5. So now it's important you pick values that will be able to graph. So let's pick -2 and substitute that in for x. So that's parentheses -2 cubed plus 5. Well, -2 cubed is -8 plus 5 is -3. Okay, now let's substitute -1. So -1 cubed plus 5. Well, that's -1 plus 5 is 4. Okay, 0 cubed plus 5 equals 5. 1 cubed plus 5 equals 6. And 2 cubed plus 5 equals 8 plus 5 is 13. Okay, now let's graph our points. Okay, so -2, -3, so -2, -1, 2, 3. Okay, -1, 4, so -1, 1, 2, 3, 4. 0, 5. 1, 6. And then 2, 7, 8, 9, 10, 11, 12. It's a little below where it is, but that's close enough for our graph, okay? Okay. Now, very simple. Now that you've graphed f of x, finding the inverse is simple. You just switch the x and y. So the new x values are -3, 4, 5, 6, and 13. And let's try to straighten our table up. Okay, and then our new f inverse of x values are -2, -1, 0, 1, 2. Okay, so now let's graph that. So -3, -2. So -1, 2, 3, -2. 4, 1, 2, 3, 4, -1. 5, 0, 6, 1. And then 10, 12, 13, 2 is probably right there. Okay? All right? Now, if they're inverses, they're going to reflect over the f of x equals x line, which is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. Okay, And you see here that they reflect over that line, so they are inverses. All right, let's take a look at example 2. Okay, so now we need to evaluate f of x with different x values. So let's use -6, 1, 2, 3, and 10. Okay, so that's the cube root of -6 minus 2 plus 3. Okay, well, that's -8. The cube root of -8 is -2 plus 3 is 1. Okay, now let's do the cube root of 1 minus 2 plus 3. Well, the cube root of 1 plus 3, that's, oh, wait a second. I'm sorry, the cube root of -1 is -1 plus 3 is 2. The cube root of 2 minus 2 plus 3, well, that's 0 plus 3 is 3. Okay, and then the cube root of 3 minus 2, so that's 1 plus 3 is 4. And then the cube root of 10 minus 2 plus 3, well, that's 8. The cube root of 8 is 2 plus 3 is 5. Okay, so let's graph our points. So -6, 1, so -1, 2, 3, 4, 5, 6, 1. Okay, 1, 2, so 1, 2, 2, 3, 3, 4, and then 10, 4, 5. Okay, now for the inverse, real simple, we switch the f of x and the x, so that's 1, 2, 3, 4, 5. Let's fix our table. Okay, and then -6, 1, 2, 3, 10. All right, so 1, -6, so 1, 2, 3, 4, 5, 6. 2, 1, so 2, 1. 3, 2. 4, 3. And then 5, 10. Okay, and if they're inverses, they're going to reflect over the y equals x line. Which you can see here. You can see here that they reflect over the f of x equals x line, so they are inverses. Okay, go ahead and finish up example 1 and 2. Okay, now let's take a look at example 3. Okay, find the inverse of each function. Okay, now define the inverse, and put some light shining through there. I think what I'm gonna have to do is slide my camera over, do some adjustment there. All right, there we go. Try to keep the sun out of the paper, or off the paper, I should say. All right, so to find the inverse, first let's change f of x to y. Okay, and then switch x and y. So, wait a second, I'm trying to run from the sun. Let's see. Oh, wait for it. Ha, I think I got away from the sunlight. All right. Oh, almost. We're almost away from the sunlight. There we go. Now I think we ran away successfully from the sun. All right. So now that we've gotten away from the sun, to find the inverse, we switch x and y. So x equals -y plus 3 cubed minus 4. Okay. Now we're going to resolve for y. So we're going to add 4 to both sides. So that's x plus 4 equals negative. I'm going to put a 1 there, parentheses, y plus 3 cubed. Now we need to divide both sides by -1, so that's x plus 4 divided by -1 equals y plus 3 cubed. Okay, now we're going to take the cube root of both sides. Now, let's do kind of two things in one here. If we divide everything by -1, we can get rid of the fraction. So that becomes a cube root of -1x minus 4. And then the cube root uncubes, so y plus 3. Okay, now last step, we're going to subtract 3 from both sides. So then you're left with the cube root of -1x minus 4 minus 3 equals y. Okay. Let me try to clean this cube root up right over here. There we go. All right. So go ahead and finish up example 3. All right, let's take a look at example 4. Okay. Now this, I think I made a mistake. I forgot the y, so we're going to add that equals y. Okay. Now we're going to switch x and y, so that's y minus 1 cubed minus 1 equals x. Okay, now we're going to resolve for y. Okay, so we're going to add 1 to both sides to get y minus 1 cubed equals x plus 1. Now we need to take the cube root of both sides. This uncubes the cube, so that's y minus 1 equals the cube root of x plus 1. And then last step, we're going to add 1 to both sides, so y equals the cube root of x plus 1 plus 1. Okay, go ahead and finish up example 3 and example 4. All right, let's take a look at example 5. Okay, let's change f of x to y, and you're going to switch x and y. So x equals 2 cube root of y plus 3 minus 1. Try to refocus this a little bit. All right, we're going to add 1 to both sides to get x plus 1 equals 2 cube root of y plus 3. Oh boy, see that the sun's chasing after us again. All right, got away from it again. All right, so now we're going to divide both sides by 2, so you're left with x plus 1 divided by 2. It's a terrible one. I'll try to fix that. Much better. Equals the cube root of y plus 3. Now we need to cube both sides. So then this becomes x plus 1 cubed divided by 2 cubed is 8. Now, so to kind of running out of space, we're going to do kind of two steps in one. The cube uncubes this cube root, and you're left with y plus 3. If we subtract 3 from both sides, left with equals y. Okay? All right, finish up example 5. All right, now example 6. All right, change f of x to y and switch x and y. So x equals a cube root of y minus 3. Now we need to cube both sides. So then you have x cubed equals a cube uncubed, so that's y minus 3. If we add 3 to both sides, you're left with x cubed plus 3 equals y. Okay, go and finish up example 6. All right, now let's take a look at example 7. And it's not on my paper, but let's go ahead and add example 8. Okay, now determine by composition whether each pair of functions are inverses. Okay, so let's start off by doing f of g. So f of g. So we're going to put in g into f. So that's parentheses cube root of x minus 3 plus 3 cubed. Now, there's nothing you can do because this minus 3 is underneath the cube root and that's on the outside, so they can't cancel each other. So you can't simplify this anymore. And if you can't simplify it and you can't get x, then you stop and we say that f of x and g of x are not inverses. Are not inverses. Okay? Now let's take a look at example 8. So we do f of g. So you're going to substitute g of x into f of x. So that's the cube root of x cubed. Well, this uncubed root, so you're left with just x. So far, these could be inverses. Okay? Now let's try g of f. So now we're going to put this into g of x. So that's cube root of x cubed. Well, the cube root uncubes the x, so you're left with x. Since f of g equals x and g of f equals x, we can say that f of x and g of x are inverses. Okay, go ahead and finish those examples up and start working on your